Hello and welcome to the National Astronomy Meeting here in Nottingham on a nice sunny day. I hope you can hear us. My name's Anita Heward. I'm the press officer for the Royal Astronomical Society. With me is Leigh Fletcher from the University of Leicester, who is one of the scientists who is getting very excited about the Juno mission, which is due to arrive at Jupiter next week. So Leigh, good morning.
Good morning. How are you doing? We have, we're waiting for people to join.
We are waiting for people to join. So maybe if we just kind of hang on just for a moment or two and see whether we can encourage a few more people to join us. Okay. Do we have any viewers? We don't have any viewers. That's a bit disappointing.
I'm watching you at the moment.
You are?
Yeah. Oh no, it says that I'm watching you.
Okay, so we do have people there. So I think we just have to carry on regardless.
Yes,
Can you hear us, Tamila?
No. Well, hang on.
Oh, we have. Excellent. We have 2 viewers at least, so we have people with us.
Fantastic.
Excellent.
Fantastic.
Good. So, good morning. And yes, Leigh. So it's exciting times.
It is. We've got 7.5 days to go until Juno is about to arrive at Jupiter. And I think the whole community, whether you're a professional scientist, whether you're an amateur scientist, whether you're just someone who gets excited about these sorts of events, is getting more and more enthusiastic about this mission as we get closer. Because of course, Juno is going into such an unknown environment. We've never been quite so close to Jupiter before. We've never been, crucially, into these things they call the radiation belts around Jupiter. And that's an environment where you've got these high energy electrons whizzing around Jupiter, being accelerated to speed close to the speed of light. And that will just mean that our heroic spacecraft is going to be taking a battering over the next 20 months when it gets there. But of course, we have to survive the next 7 days, this crucial period we call Jupiter orbit insertion. So everybody's squared up and willing to go.
All pretty exciting times. Now we have some questions that have been submitted by schools today.
Okay.
And so let me just bring those up. I mean, maybe you could just give us a bit of an introduction, first of all, to Jupiter itself.
Okay.
What's the planet? What's the planet like?
Okay, so Jupiter is the largest of our collection of gas giant planets in the solar system. We have 4 giant planets: Jupiter, Saturn, Uranus, and Neptune. And Jupiter is our kind of closest and best example of what it really means to be a giant planet. It's entirely hydrogen and helium gas with a few small traces of other molecules and other elements. And we call those elements heavy because they're all heavier than hydrogen and helium. And one of the things that Juno is deliberately trying to do is to try to get to how many of these heavy elements are present within Jupiter, and are they located within a core? Because although we've seen Jupiter for generations and generations, and we've studied it for many decades, we still don't know the answer to that basic question. Is there a core somewhere deep down in the center of Jupiter? So hopefully in the next 20 months, with Juno being there, we'll actually get an answer to that question.
So we've got a question from Hammond Junior School.
Okay.
They wanted to know, how close to Jupiter do you expect to get with Juno?
Okay, roughly 5,000 kilometers. Okay, so it's going to be doing this orbit, whereas if you think of Jupiter as the size of a football or a basketball, it's going to be doing an orbit that takes it very, very close in at the equator, and then whizzes back out over the South Pole, and then goes back in over the top again, and whizzes back close to the equator. And at that point near the equator, it'll be 5,000 kilometers away. To give you an idea, if it was a basketball, that's about a fingertip's width away from the cloud tops themselves. So as I say, with the cameras that are on board, you can imagine having such exquisitely high resolution photographs of features on the surface of Jupiter. And I think everybody's holding their breath to see what it's going to look like.
So Jupiter itself is this great big ball of gas. amazingly spectacular clouds
Yeah.
and storms. Hillcroft Primary School wanted to know, why does Jupiter have this big orange dot?
The great red spot.
Yes.
That's a question that even scientists are still wrestling with today. So it's an excellent question. What we believe is that this is a giant raging storm system. It rotates anti-clockwise as you look at Jupiter. And if you were on some incredible sailing vessel that was able to be within that great red spot, you go around the exterior once every 3.5 to 4 days. That's how fast the winds are blowing. But this is absolutely enormous. It's about the size of, you can fit 3 Earths across the interior of the great red spot. So it's a fabulous feature. Why it's there is still a mystery. Something about the winds that is embedded within means that those winds can split up and form little, we call them eddies and vortices. If you look at the jet stream on Earth, it meanders back and forth for the same reason. It's an unstable wind pattern. And sometimes those little eddies can start to roll up. And as they roll up, they take all the energy from the wind field, and they can grow larger and larger and larger. And in some circumstances, you can get a large storm like the Great Red Spot. Why it's red is a question that we still don't have the answer to. We think it could be to do with some phosphorus compounds, maybe sulfurous compounds, but things like the Juno mission are required to answer those sorts of questions.
So the Hillcroft Primary School again say, has Jupiter got an outer layer of gas, and why doesn't the gas float away?
So it's all to do with gravity itself. Gravity holds everything together, and Jupiter's gravitational field is one of the largest things in our solar system, second only to the sun itself. And of course, that gravitational field is holding the satellites of Jupiter in orbit around it. It's holding the ring system of Jupiter in orbit around it, and it's holding all of the gases that were contained within Jupiter close to the planet itself, preventing them from eking away and escaping. And one of the nice things about Jupiter, we like to call it a time capsule, because it is so massive. All of the stuff that was incorporated into Jupiter when the planet first formed is not allowed to escape again. So all of the materials that were there when our planets were forming are still contained today within Jupiter, like a 4.5 billion year old time capsule.
Gosh.
Yes, that's why we're going. See? That's why we want to be there.
So again, Hillcroft Primary, they had a lot of questions about Jupiter's moons.
Okay.
Why does it have so many? What are they named after? And what's the biggest?
Okay, the biggest is Ganymede, without a shadow of doubt. Ganymede is actually larger than the planet Mercury. So if it was off floating by itself out there in space, it would be a fully fledged planet in its own right. The 4 main ones, Io, Europa, Ganymede, and Callisto, named the Galilean satellites after Galileo Galilei, who discovered them in the first place, are fascinating places for us to one day go and explore, because we believe that the conditions might be just right on the surfaces of those moons to permit habitable conditions. So they have all the ingredients there for life to potentially exist. Now, not to say that life does exist, but it does suggest that we should go and explore those bizarre surfaces to find out more about them.
And so Juno is mainly focused on Jupiter
itself. That's right. Yeah. The next big mission out to the Jovian system will be something called JUICE, the Jupiter Icy Moons Explorer, and that'll go in the 2020s to arrive at Jupiter in the 2030s. And the hope is that that particular mission will do a very, very detailed survey of the satellites and all the moons that are there to try and answer this question. Could life potentially exist on the satellites or in their, beneath their surfaces, for example? But Juno is very focused on Jupiter and this central question of how did Jupiter come to be, and does it have a core of heavier elements down there deep within in the centre, hidden from our view, if you like.
So back to Juno itself. I mean, I think one thing perhaps we should make clear is that this is a robotic spacecraft.
Yes.
So the only people on board, or there aren't people on board, but there are some characters on board.
There are characters on board. Yes, there are 3 little Lego characters. I don't know. It's I think Jupiter himself, Juno, his wife, and then Galileo, a little figure of Galileo. The little, I believe, they're aluminium figures. And the reason for that is just to try to open people's eyes that now, where we are today in exploring different planets in our solar system, is we've now got 40 years of history of doing this sort of exploration to build upon. And we want to just engage the general public much more in this process of trying to learn more about Jupiter and also our place in the solar system itself. because we think Jupiter, its formation in the first place, had a huge influence on the formation of our planetary system. It redistributed the other gas giants to where they are today. It flung material around the asteroid belts, so it left all this debris of solar system formation, and it allowed the conditions to evolve on planet Earth, on the terrestrial planet, to allow us to even have this conversation today and think about the origins of the solar system.
And it still today has an effect on our solar system. It still affects the other material that's flying around there.
That's right, it does. We don't actually know whether it's doing a good job for us or whether it's doing a bad job, because of course every now and then we see these impacts happening on Jupiter. Comets collide with it, asteroids hit it, leave large debris scars on the planet, and that could be evidence of this thing acting as a giant hoover bag, keeping all this debris of solar system formation from hitting anything in the inner solar system. But it could also be shaping the impact population and sending things our way. But I think that the message is that Jupiter, the presence of Jupiter and the formation of Jupiter is pretty fundamental when it comes to understanding our solar system itself. That's what Juno is aiming for, trying to address those questions.
So you touched on this a bit before. One of the questions from Hillcroft Primary was, does Jupiter have any oceans?
Okay. That's a challenging question, and I'll tell you for why. Because although we call it a gas giant, at the centre of Jupiter, the pressures and the temperatures will be really, really alien to what we're familiar with here. There'll be extremely high pressure, extremely high temperatures. And that means that the distinction between solids, liquids, and gases becomes rather blurred. It's taking a gas and compressing it, almost to the point where it behaves, if not like a fluid, then potentially like a solid. And we call that solid metallic hydrogen. You've got hydrogen is made up of a proton and an electron. And if you squeeze it and squeeze it and squeeze it enough, that electron is allowed to escape. And it can actually enable currents to flow within this metallic hydrogen layer. Now, we can produce that here on Earth, but we can only do it for a fleeting instant in high pressure experiments. Between two diamond anvils, we can compress hydrogen together to be that much. But yes, the idea of it being an ocean, well, who's to say that it's not? It's certainly fluid. That's the basic parameter we think of for a giant planet.
Hammond Junior School have asked how long it's taken Juno to get to Jupiter.
We launched in August of 2011. Okay, so it's taken 5 years really for us to get out to Jupiter, and it's done a gravitational slingshot that most spacecraft do. They fly by other planets to take some of that gravitational energy to speed up the spacecraft so we can go out to the orbit of Jupiter itself. Something like the JUICE spacecraft in the 2020s will take about 7.5 years, and that's simply because of a slightly different alignment of the planet and how big the rocket is to set us on our trajectory. So there's a lot of nerves. We've got to be waiting 5 years for this sophisticated spacecraft that you've built to do the job that it's been designed to do. I
mean, that's another question from Hammond School, is how many people have been involved in this?
Oh, hundreds and hundreds and hundreds, if not thousands of people. From the engineers up to the scientists who are going to exploit the data. I should say as well that I'm not officially part of the Juno team per se, but what I am trying to do is use ground-based telescopes across the globe to support some of the activities that Juno is going to be undertaking over the next few months. It's one of those. The idea is that because Juno will be doing such a high level of scrutiny of the giant planet, we want to take that opportunity and make the most of it by having telescopes on the ground observing slightly different wavelength ranges, slightly different ways, so we can bring all this data together to teach us a lot more about Jupiter.
I'm just trying to see whether I could possibly show you some of the images that Leigh has taken. We've got some fabulous images that have come out today.
Yes, the European Southern Observatory out of Chile, up on the mountains in Chile, and also the infrared telescope facility out in Hawaii. I've been very lucky to use those telescopes in the past to take observations of Jupiter. And what we've been doing over the last 5 or 6 months is taking regular observations of the giant planet to try and characterize what its atmosphere looks like today ahead of the observations that Juno is going to take. So it's like a pre-characterization to set Juno's findings into a wider context. I think we're just about to.
I'm trying. Here we go.
Those up on
Right.
screen now. Yeah.
So this is, hopefully, this is one of the images that Leigh has taken.
I was particularly proud of this one because this is one of the highest resolution views we've ever obtained at this wavelength. This is a wavelength called 5 microns, and so it's longer than the wavelengths that we see sort of visible reflected light, sort of, as we see here in this room. But what you can see there is Jupiter's deep internal glows. You can see the fires of the insides of Jupiter, if you like, and that is being emanated from Jupiter, and you have clouds sat over the top in silhouette. So when you see dark regions there, that's because the clouds are blocking the light from escaping. Where you see bright coloured regions, those are gaps in the clouds, allowing this internal emission to get out. So looking at Jupiter at these wavelengths allows us to learn a lot about the atmospheric structure below the levels that you can see normally in reflected light. And
here's another one.
Yeah, so these are observations taken in even longer wavelengths, out into what they call the thermal infrared.
Is it? Yeah. Got it.
So you can see the great red spot just here, and you can see another vortex on the right-hand side of the screen. That's called oval BA, another large red storm system. And these wavelengths allow us to diagnose what the temperature of Jupiter is like. So it's like taking the temperature with a thermal infrared camera here on Earth. You can see the heat energy being given off by something, and that's what you're looking at in that particular image. You're looking at the heat of Jupiter, and you can see the great red spot turns up as very cold, so does the equator, so they've got dark colours, and the two belts to the north and to the south, they show up as nice and bright. They're warm belts due to the way in which the atmosphere is circulating. So these sorts of images we cannot get with Juno. Okay, that's the reason we're trying to do them from the ground. They will support the Juno spacecraft's observations as we take them.
Brilliant. More questions.
Yes. Okay.
More questions. So, do you have any idea how much the Juno mission has cost? This controversial one.
No, not really. Ballpark figure to get anything out to Jupiter, it's going to cost you many millions of dollars and many millions of pounds or euros to actually get out there. This one, I think the estimate for the entire mission, sort of start to finish, is around about $1 billion, which is the NASA and the European Space Agency and all the other space agencies around the world. Their budgets are fairly strictly laid out on a year-by-year basis, and the science community then says, well, here are the big questions we would like to solve. And it was back in the early 2000s that this idea of sending a new mission to Jupiter to address its origins and its formation really came up. So that money, the US Space Agency said, well, this is the question we're going to address with this money that we have. And hence we have Juno, so that everybody's getting excited about what it's going to do.
And so where is Juno now?
Juno is 7 days away from Jupiter. Okay, it's getting close enough. Jupiter's getting bigger and bigger out the windows, if you were sat on board, that in 7 days' time, it will use its main engine, burning for about 35 minutes, to slow down and actually go into orbit around the planet for the first time.
And so how far does it, do you know how far it's got to go?
I don't have
sorry.
Sort of fixed there in my head, but I do know that there are images that you can find out there on the internet, which the cameras are now taking data. They're taking data that will allow you to see Jupiter, and you'll see the dance of these satellites that you asked about earlier. They'll be moving around on a few-day period. And so some of those stills from that movie are already available. And after Juno gets there, the full movie will be downloaded from the spacecraft and made available for people to take a look at. So everybody's waiting with bated breath to see that. Of course, Juno will not really be doing science during that crucial maneuver. Its instruments will be turned off, and it will be, once it gets into orbit, there's then a very long period of checking the instruments are all okay, checking the orbit has gone as planned. These things, they do have risks involved in them, of course, every space mission does, but we've been rather successful over the years getting to the outer planets. Big gravitational wells, we just need to get into them and survive. And its proper science will really begin in around about November of this year. It will be in this fortnightly orbit. So every Monday or Tuesday for every 2 weeks, for a period of about 20 months, Juno will be doing this close passage from north to south, 5,000 kilometers above the cloud tops. And over that 20-month period, they'll build up complete maps of Jupiter's, the emission from Jupiter, Jupiter's gravitational field, and Jupiter's magnetic field. And those 3 measurements that it will be trying to take, in addition to several others, they allow us to peer deeper into Jupiter than we've ever done before, to find out its inner workings, and to try and identify whether the core is there within the planet.
So how many probes have been to Jupiter?
So there's only one mission that's actually been into orbit around Jupiter before. That was the Galileo mission between 1995 and 2003. Sadly, the problem with the Galileo mission was that we have to send all our data back via this thing called the high gain antenna. And that is a big dish that's pointed at the Earth, and it sends the information via radio signals. And unfortunately, on the Galileo mission, the antenna didn't unfurl properly. Okay, so it meant that our data rate was really, really low. And I think in the community, there was always a sense that this was a job half finished. We really needed to get back to Jupiter to finish what had been started. Now, Galileo also sent a probe into Jupiter. Now, that's the first and only time so far that any instruments have actually been sent down into the cloud decks. And it descended in 95 under a parachute, and it sampled all the gases, and it sniffed out all the different clouds that were present. And it lasted for just over an hour, down to a level where we were expecting to see water clouds, so water clouds like we have in our own atmosphere. And sadly, it didn't see them. It didn't see those water clouds. And it was because we think we went into an unusual meteorological region, a strange bit of weather on Jupiter that just dries the whole atmosphere out like a desert region on our planet. So Galileo, the only mission that's actually gone into orbit before. We've had flybys of other missions, like the Cassini mission, was on its way to Saturn. It flew by Jupiter, but Galileo was really the benchmark. Juno is following in the footsteps of. And JUICE ultimately will follow Juno later on to go into orbit. And it'd be lovely to have one of these sorts of spacecraft at every single one of our giant planets. Those poor ice giants, Uranus and Neptune, only visited once by a flyby spacecraft. So just a few weeks worth of data actually taken for those distant worlds. It would be fantastic to have a Juno-style mission out at the ice giants.
And so, to slightly paraphrase one of Hammond Junior School's questions, so what are you hoping to get from this? What are you hoping to see most from Juno?
So I'm an atmospheric scientist, and I like studying the climate of different planets and how atmospheric processes on Jupiter work compared to how they work here on planet Earth. So things like storm systems, things like winds and how they vary over time. And on Jupiter, just like on Earth, the atmosphere is powered by a sort of water cycle. The condensation of water to form clouds is a way in which Jupiter transfers its energy from the insides up into the upper atmosphere. Now, water is really hard to observe from planet Earth because you're looking through an atmosphere which is full of water. So how do you detect Jupiter's water when you've got loads of water in the Earth's atmosphere obscuring it? So you either need to do it from a telescope in space, but that's very hard because you need a big telescope to get good resolution, or you need to go there. And if you go there, and you go there with a microwave instrument, which is what Juno is doing, you can actually map the distribution of water on Jupiter for the first time. There's several reasons why that's important. The primary one for me is that water drives the atmosphere. Water condensation drives all those beautiful patterns that we can see. But for those who are interested in how Jupiter first formed, the theory goes that water, as ice, trapped other molecules inside of it. So say you've got a methane molecule, an ammonia molecule floating about. It was being trapped in ices and water and then taking that ice and delivering it to the forming Jupiter, which is how Jupiter got its heavy elements. So the question is, well, if we don't find huge amounts of water buried somewhere deep within Jupiter, our understanding of how planets formed may be completely wrong, or it may need turning on its head. This is why Juno is so important. It could really rewrite our textbooks of how we understand planet formation in general.
And one last question from Hillcroft Primary. Do you think that humans will ever visit Jupiter or the Jupiter system?
I hope we visit the Jovian moons at some point. I'm a big fan of science fiction, I love reading these far-flung ideas that you might have some cloud base one day that you can actually exist in the atmosphere of Jupiter, floating around, powered on gigantic balloons or something like that. But that's a real challenge. Getting to a satellite, a solid surface, is also a challenge when there's no atmosphere, because you can't use a parachute to slow yourself down. You have to do it with a rocket. And I hope, I'd like to make a prediction that in the next 100 years, we will have sophisticated robotic rovers trundling around on the surface of the icy moons of Jupiter. And just like with Mars today, they are pathfinders for us one day, human beings following in those footsteps. But I don't want to hold my breath, but I am excited that that's the direction that we're all intending to go in one day, spreading out across the solar system.
Well, good luck next week.
Thank you.
I hope it all goes really well.
Tuesday morning is when it's all going to happen, and then we'll be glued to our TV screens waiting to see what happens.
Brilliant.
Okay.
Well, thank you very much.
You're very welcome. And let's hope the rest of the conference goes as it's going so far.
Okay. Thank you for listening, everybody. And if you have any further questions for Leigh, then please send them via our Google Plus page or via Twitter with the NAM 2016 hashtag. Thanks a lot. Bye-bye.
Bye-bye.